we have show a great potential application for both consumer and industrial robots. However, this is not one nice story to build robot from scratch. In the talk, from stimulation to real robots, an optimization view in mechanic design, Mr. Phuong Hoang, CEO of GraphicsMiner, will provide a working pipeline to build a real robot from mechanism design to stimulation and to construct a real robot. Then we can look at an optimization perspective of kinematics and dynamic of the robots. Please welcome on stage.
Good afternoon, everyone. So I think it's my privilege to give a talk to you guys about from simulation to real robots, an optimization view. So before jumping into my presentation, so this is the outline of my presentation. And before jumping up to my presentation, I have a very quick question. So please raise your hand if you have children. Please raise your hand. Okay, I think around 30%. So since last 2 years, okay. Since last 2 years, I and my team, we are developing a simulation Bayesian AI-based education platform to support students around the world to learn, to share their knowledge. So normally with smart devices, students, they play video games. So with the platform, now instead of playing games, now they can tell their own story. They can create many virtual scenarios, so they can learn from, mechanics, from human anatomy. They can tell their own story. And the platform does not require internet connection. It means students in rural area, local area in Vietnam, they can use it without internet connection. And even it doesn't require very high-end devices to run all this kind of simulation. So we have a privilege to meet 1,000 of teachers and students in Vietnam, and when we got feedback from our users, we understand better about their behavior and what they are looking for a real educational app. So the first question from many students, they're asking for us, for the apps, is where's my games? So I told them that instead of playing games, now you can create many virtual scenarios and you can share it. And the second question is like many students, they ask us, can we build a real robot or can we build a real mechanic? So the whole team, we shape up the attitude. We are thinking seriously about, instead of knowing it all, we should learn it all. We should start from scratch. So it's my pleasure to work with my team. They are very hardworking. So Chi, he will introduce to you our robot. So we build the robot, the real one, 25-degree freedom, and it powered by Jetson Nano as well as Arduino. So now it have a very basic function. So I think it's a very basic one, but we hope that students, they can learn and they can play at the same time. So I'm sorry if you are in the back, can you see the robot? You cannot see, right? So we have a very short video clip. Or maybe it's the next version. Yeah. So I think it's kind of, how can I say, it's very tough and kind of very challenging for a very young team. But we think that we should do something for real. And we support from many guys from Robot Shop or List Motion, and we learn it from scratch and we build it. And we think that we learn the pilot how to create a robot. I think the pilot is very, very, very important. And okay, just like. So the pilot is so important for mechanical design. We use SolidWorks, and in terms of simulation, before build a real one, we should test it, and we use Gazebo and VRAP. I think you guys can can build the SN robot on your own. I mean, do it yourself, because we're gonna release it, so you can use 3D printers and you can build it from scratch as well. But I think it's very, very challenging, so that we have a two version for students and teachers. So the SN Edu and the SN Pro for R&D. So in terms of computer vision and NLP stuff, you can integrate it, because now you see very small black box in here. So it's just a nano. It's very, I think it's quite powerful embedded computers on so it allows kind of edge computing. So all kind of computer vision algorithms which CNN model can run on it. So you can pre-order it now. Hopefully by the end of this year we can release it to all you guys. So because VietAI submit is something like, it's kind of academic submit, so we should talk about mathematical equation, right? Otherwise, it's going to be like a very advertising chance for me and my team. Just tell just a very basic robot demo. So I want to have very fun kind of game. So can you close your eyes, but don't take a nap? Can you? Yeah. So imagine that you were an insect, and how you can control your body and your legs. Because we are kind of, I mean, two-leg animal. I'm sorry, but half of it is true. But if the way we understand the way we control an ant robot, we can control many other types of robot, right? So the foundation for controlling the robot is all about inverse kinematic and inverse dynamic. So suppose that my whole body is like a robot, and this my arm is like a leg, the ant. And if I want to reach to that point, so how many possible trajectory can we guess? I want to reach to that point. How many possible trajectory? How many possible ways? Because when we're working with robot, we need to control it, and the algorithm to control is like it should be kind of general one, right? So how many possible ways? Suppose that I want to reach to that kind of target, and this is my leg. Suppose I were an ant robot. So how many possible ways? Yeah, you're right. So I can reach by this way, or that way, or many other ways, right? So we should control the robot with the optimum way. I mean the least energy way, right? So think about it as like an optimization problem. So you see on the right, you see that it's got a very basic least square optimization problem, but sometimes it doesn't work because of the inverse matrix doesn't exist. So that we can use a kind of iterative solution to solve it. and many iterative solutions already proposed by many research groups around the world. So I mean, even in the ant robot, you see there are many equations already shown on the body of it. I mean, inverse kinematic of the body and the legs. But inverse kinematics is not enough because my body is kind of quite light. I'm sorry, but I think only 60 kilograms. But suppose that I'm now 200 kilograms. So the speed I move too fast, it's gonna break. It's gonna break, right? So inverse dynamic is something that supports you to find the best answer, to find out the way you can control the robot. And inverse dynamic is, you can see on the right, the same thing. It's like optimization and the least square problem as well. So I'm sorry for mentioning a lot of fashion term, but yeah, we can. But when you can control the body of the robot, I think it's not enough, right? The robot should, right now, it should have their own, kind of AI stack. I mean, different level of pattern recognition, and then it should have a kind of their own perception and the cognition. So if this guy control it, I think it's okay. But if you think about this kind of robot, is like an autonomous one. It should have its own perception and cognition. So think about this image. I'm sorry if you can see the number 1 and the number 2. Okay, Tuấn đã ảnh xuống. So you see the number 1. Number 1 is a button recognition, the very basic one. I think the lowest level of AI. So that we utilize a kind of computer vision, right? So it can recognize some kind of the red box and the chairs and all the surrounding context. But in the number 2, the perception, it should understand where it is in the context. Suppose that the robot is autonomous, it's fully autonomous, right? So it's gonna be very challenging, I think. So that even in the last one, cognition, it requires a lot of computation to let it to be the kind of autonomous agent. So I think, I'm sorry. So from perception to control, you think about the state estimation. So normally a lot of research groups they are using kind of standard Kalman filter or a different version of Bayesian filtering. So I think it's kind of very sophisticated and many sophisticated algorithms right now to estimate the state of the robot, and then we're gonna use all that kind of equation from kinematics, dynamics to control it, and I think lastly we can have the torque and the joy angle to control the robot. So think about the Bayesian filtering is the same thing. So you see here the robots in the room, the xk-1 is the time step and the state, and then it's gonna move to xk. So when it's gonna move to the xk, it should understand the context to get better understanding about the location of the robot. So if we can solve all that kind of equation, it's gonna be great. Otherwise, I think the robot can fall down easily. So I think it's very, very challenging for anyone to join, to join kind of hardware stuff or robotics. So we think that we should open it, and you guys can, contribute. And I think you guys are way better than us, and you can support us, and you can support the community. So yeah. So can we have time for a very quick demo for the Jetson Nano quick detection? first person view from the robot. So you see, sorry, the robot sometimes can recognize the person. Or you, at least there's one person. So I think yeah. So it brings me to the end of my presentation. So, hope that you can improve it and make a good one. And it's going to be great to see all kind of experts who can contribute to kind of open source project.